Hello everyone and welcome to our webinar. My name is Johanna Manso and I am the Logistics and Events Manager for Internet Systems Consortium and I am your host for today. The title of our presentation today is IPv6 Migration, Some Lessons Learned. And our presenters for today are Mr. Peter Lauscher, Senior Operations Architect of Internet Systems Consortium, Mr. Timothy McGuinness, Manager of Training and Education at Internet Systems Consortium. Timothy will also be our moderator for today. Mr. Jeffrey Simpson, Consulting Engineer for DNS-OARC, and Ms. Suzanne Wolf, Strategic Partnership Manager for Internet Systems Consortium and President of DNS-OARC. Several quick points before we begin. This webinar will run for approximately 1 hour. All webinar participants are automatically muted upon entry. This webinar is being recorded and the recording will be posted on our website within 3 business days. If you have questions for us, please go ahead and type them into the Q&A area in the bottom right-hand corner of your screen. We will answer them during the short breaks or at the end of the session. Now, without further delay, I present to you Timothy. Go ahead, Tim.
Thank you, Johanna, and welcome everyone to this introductory IPv6 webinar. I am Tim McGuinness, the Training Manager at ISC, and I have a decade of experience with IPv6 numbering policy, consulting, and training. I said introductory webinar because this is intended to give you an idea of what IPv6 is, where we are in deployment, what ISC has done and is doing, and some lessons learned. We will be doing more in-depth IPv6 webinars later this year, and those will be more technical in nature. So today, Jeff Sisson from OARC will have some interesting V6 data from the last few days of the post-IPv6 launch day monitoring. And Peter Lauscher will give some insights and data from an ISC operational point of view. And we'll have plenty of time for Q&A interspersed with the presentations. But I'll try to explain why we need a next generation Internet protocol, some design decisions, and some drawbacks to those decisions. Initially, IPv6 was envisioned due to the knowledge that in a very successful Internet landscape, IPv4 has a finite set of numbers. And to continue the growth of Internet working, we would need more numbers. This is especially true today as one of the regional Internet registries has already reached their last /8 block of IPv4 addresses, triggering what's called a rationing policy. 20 years ago, when the IETF first started on what is now IPv6, it was also true. But CAIDA, or the classless interdomain routing, and NATS, network address translation, gave IPv4 a new lease on life that has lasted into this decade. However, in the next 3 to 5 years, all of the RIRs will be functionally out of IPv4 address space. So IPv6's main function is to give us a much larger address space. The IETF wrote the original IPv6 RFCs, which allowed the IANA, the Internet Assigned Numbers Authority, to do their job of allocating to regional registries, as well as recording blocks for special purposes, for instance, multicast. The address space the IANA allocates from is 128 bits long in IPv6, as opposed to 32 bits in IPv4. As most of you know, when you add a bit, you double the address space. So 128 is not just 4 times 32, but it's actually 3.4 times 10 to the 128th power, or more than 40 billion addresses. Or if you're British, it's 340 sextillion. If you're American, it's 340 unidecillion. That, of course, is a lot of addresses. But so was 4 billion in the early days of IPv4. In order to ensure that we don't repeat some of the same mistakes in terms of allocating too much in the early days of IPv6, IANA is only allocating from 1/8 of the possible address space, keeping 7/8 in reserve. And you see that on your graph on the slide. The 3 leftmost bits are reserved. With that in mind, the RIRs began allocating IPv6 over a decade ago to local internet registries, who are ISPs, telcos, carriers, enterprises, and exchange points. So that step is largely done, but there are still many who have not gotten their allocations despite lenient IPv6 allocation policies across the globe. The RIRs are also doing education and outreach around IPv6 in their own region, trying to encourage deployment. The next group of actors who rolled out V6 are many of the top-level domains and IXPs. Most major IXPs have had a V6 peering mesh available for many years. The large generic top-level domains, .com, .net, .org, also have IPv6 records in the DNS, as do many of the country code top-level domains. One of the barriers to deployment has been finding a native IPv6 upstream provider, but more and more transit providers can now give you IPv6 connectivity. However, we are still a long way from having all transit providers offering IPv6, but you can get it from nearly all of the tier 1s at least nowadays. So the pioneers have paved the way. Early adopters are moving fast, and it's not too late to start thinking about IPv6 for your organization, which I guess is the reason you are attending today. So I wanted to give you a quick look at the IPv6 address format for those unfamiliar with it. As you can see from the slide, there are several ways to represent a single IPv6 address. So all the ways you see on the screen are functionally equivalent. They're all valid IPv6 address formats. To our IPv4 eyes, this is really unsettling, but since software can read and differentiate between different V6 address formats, we don't have to do the differentiation ourselves. There is also a whole alphabet soup of acronyms for transition techniques, all of which sort of fall into three broad categories. The first category is dual stack, where you can run V4 and V6 on all of your network interfaces. This is in many ways the simplest path to take, and it is the one that most of the internet technical community recommends. The second category is to use tunnels. So for example, if you can't get native IPv6 upstream, a tunnel will allow you to encapsulate V6 packets inside V4 packets. The third category is translation, which allows V6-only devices to communicate with V4-only devices. And the loopback in IPv6 is actually human readable. As you can see, it's :1. One of the major stumbling blocks to IPv6 deployment is that it is not compatible with IPv4. The graphic in this slide is a side-by-side comparison of the V4 and V6 packet headers. As you can see, the V6 header is greatly simplified, with only 8 fields compared to the 13 fields of IPv4. This was done in IETF by design, but the folks in the IPNG and the IPv6 working groups didn't foresee the lack of backwards compatibility as being the large barrier to IPv6 usage that it has become. There are a number of design characteristics in IPv6 that mandated these different packet headers, more efficient routing, ease of renumbering, things you see on your screen. The advantages will only be apparent in the long term. So the problem is that we have short-term pain with long-term gain. Other reasons that V6 hasn't had the uptake its designers expected is that there is no deadline or flag day where everyone would stop using IPv4 and start using IPv6 on a certain day. The installed base of IPv4 is just too large to make that practical. In addition, there is no single organizing body telling networks that they must do this transition. Each network decides for itself what protocols to use, and that is at the heart of the internet and internet working. So low demand from customers also inhibits IPv6 uptake. End users just want their tubes to work, as you know. The protocol in use should be transparent, or at least a non-issue for end users. So last week I asked some of my ISC colleagues about their IPv6 launch day activities. And one said, well, it's time for my annual rant to my ISP as to why they won't give me IPv6 connectivity. But I suggest that he is in the 1% of folks who demand IPv6. As an aside, I have never been able to get IPv6 connectivity from any of my upstream providers. There are also costs involved with IPv6 due to the lack of backwards compatibility. It's going to cost money in terms of training staff, changing software, perhaps. Enterprises certainly will have custom software that may expect an IPv4 address, and they will probably have the biggest costs. So little demand and some costs mean that companies have little motivation to use IPv6, especially as it means spending money now but seeing little return on the investment, except, of course, that they will be able to continue to grow their network in the years ahead. What this all means is that we are going to be transitioning from IPv4 to IPv6 for several decades, if not longer. So this might be a good time to stop for questions. Does anyone have any questions they want to give on the big picture? No? If not, feel free to just type them in any time, and I'll carry on. So this is your World IPv6 Launch Day. It's being organized by the Internet Society, or ISOC, and these are the slogans that they've been using. ISOC is one of the main bodies pushing IPv6 deployment, along with the regional Internet registries, ICANN, and top-level domains. And last year, on June 6th, many companies committed to turning IPv6 on as a trial to show folks that nothing would break when they did it. This year, those companies and many more have turned on IPv6 and will leave it running going forward. In other words, it's probably the next best thing to a flag day we'll ever see. So last year was a trial, and this year this time's for real. As you can see from the list at the bottom of this slide, many of the top content providers and other network operators have turned on IPv6 last week, if it wasn't already running on their networks. Many of these organizations already had IPv6 in use, and we will see some graphs of the impact that IPv6 launch day has had in just a minute. There are a variety of metrics available regarding IPv6 deployment, and one of them is the number or percent of websites that are reachable via IPv6 transport. Our friends at Cisco crunched the numbers before IPv6 launch day, and they estimated that over a quarter of all web content will be reachable by V6 after launch day. Other estimates vary, though. For example, last month I attended the African Internet Summit in the Gambia, and one large telco suggested that since Google and Facebook make up more than 40% of his network traffic, and since they have enabled IPv6 across their network already, they will now see nearly half of their traffic on IPv6. So taking a look at some of the IPv6 launch day measurements is interesting. In this slide, we see that of the Alexa top 1,000 websites, a little over 9% are V6 reachable as of last week. And the graphic also shows that of the companies who said they would try to turn on IPv6 last week, nearly 70% were able to do so for their website. So we take Google as representing a popularly visited website. We get a perspective from this graph. While the number of users reaching Google from IPv6 addresses has gone up dramatically in the last 18 months, the peak is still less than 1% of total users. So this may indicate a last mile issue, which we will discuss in a few minutes. The idea that IPv6 is not yet widely used is confirmed by the Atlas project numbers, which you see in this slide, where we see what they call a doubling of very small numbers during IPv6 launch day. So the red on the graph, the bulk of the traffic, is 6 and 4 traffic, which is a tunneling mechanism, as is Teredo, which is the blue traffic. And as you can see, the native end-to-end IPv6 is a very small percent of the total indeed. IXPs already had a significant amount of V6 traffic. Many IXPs have seen this doubling of small numbers. As we can see in this IXP graph from Amsterdam, the AM6, they are doing 4 gigabytes per second of IPv6, which is not a small number until you consider the total traffic at AM6, which is averages 1 terabyte per second. So in terms of networks or autonomous system numbers, in other words, networks that have unique routing policies, we see in some regions that up to 10% of networks are announcing IPv6 prefixes, with the average being around 7%. The average is the yellow line in the graph. And as I note on the slide, this is not hard to get done and is usually one of the first steps in IPv6 deployment. You get your IPv6 allocation and you announce it via BGP. So the last mile, that's one of the greatest challenges we have to universal IPv6 deployment. While several US large networks have taken V6 past the trial stage, you have Comcast and Time Warner Cable are the two most often cited large US providers who are giving IPv6 connectivity to their customers. Some Japanese and South Korean providers have been V6 enabling their customers for several years, even in mobile settings. But these rollouts are non-trivial. They took many years of planning and getting buy-in from internal departments, partners, vendors, etc. Many SOHO, the small office, home office routers, still are not ready or fully IPv6 capable, although you can get one at a big box store if you do your homework. Flashing a router with custom firmware works, of course, but doesn't work at large scale for providers. The big motivation for using IPv6 may come from the last mile, however. Currently, we see the need for a larger address space in mobile networks, and when really large sensor networks come online, IPv6 will be the solution for addressing them. So, questions. We have several already. How long do you anticipate a mixed mode environment of IPv4 and IPv6 being the norm? I guess it depends. I'll take that one. I guess it depends on what you consider the norm, but I think most folks are thinking 30 years to 50 years. And we've had 10 years of experience, and we're just at a few percent now. So several decades is, I think, the answer. Okay, so Bill Kish has a question. Do you see tunnel brokers like Hurricane Electric as an important part of the eventual transition to IPv6? And I guess I can try and take a stab at that, but Jeff and Peter, if you want to jump in, please feel free. Well, certainly, I've used a Hurricane Electric tunnel for at least 5 or 6 years. I lived in Africa, and there were very few folks in my part of Africa who were providing IPv6 connectivity. If you look at the Hurricane Electric website, you will see that they are providing transit to more than 50% of the IPv6 network currently. So, yes, I think that they are an important part of the eventual transition to IPv6. Jeff or Peter, do you want to add something to that?
I'll add one quick thing. I think the service that Hurricane Electric offers is invaluable. I think it's fantastic for the internet enthusiast who wants to get experience ahead of the curve. But I don't think that tunnel broker services will significantly facilitate deployment at the scale that we need to see deployment happening. I think they're necessary, but not sufficient.
Yeah, I think that's probably about right. I mean, you and I are the 1%, and we're the ones who are going to set up tunnels with people like Hurricane Electric. And
exactly. Go ahead.
No, I was going to say that people like us and the people on this webinar are the 1%.
Exactly. And I encourage everybody who's on who hasn't had any experimentation with IPv6 to look into getting a tunnel through Hurricane Electric. I've had one for a few years too, and it provides some extremely invaluable insights into what it's like to use V6. But it really is an enthusiast, but in my opinion, I should say, unless, and this could also completely change, perhaps other services will be offered that will make it scale better, but the way Hurricane Electric and other tunnel brokers are working right now wouldn't scale to the sense that it would really affect significant migration. And again, I'm just emphasizing that that's my opinion.
I think you're probably right. And from Saif from Iraq works for a regulator, ISP regulator, and they want to push work with IPv6, and I think that's great. And you want to contact us offline after the webinar, and we can talk about next steps. So let me carry on with talking about what ISC has to do with IPv6. To support our mission, which you can see in quotes on the slide, we've been happy to make all of our software v6 usable for many years. We've also created some software to help ease the transition path for network operators. While we think that IPv6 is the future of an interconnected internet, we are more practical than evangelical. So we do what needs to be done. Peter will tell us more about our operational side, but as an example of being practical, all of our FRoot servers are v6 capable. However, only the ones that have IPv6 transit are reachable via IPv6. And Peter will show you a map of those later on. In terms of training, we run a 2-day or a 3-day IPv6 course, and these are given at different places every quarter. We also offer private courses on IPv6. We offer a DHCP course, which covers some IPv6 aspect, and our 3-day and 5-day bind course also covers some many IPv6 DNS issues. Our software is v6 compliant. Bind is our flagship name server software, and that's supported IPv6 since Bind 8. Bind 9 provides full support for the Quad A records, which is the address records in IPv6, and full support for operation over IPv6 transport. Bind 9.8 and later includes DNS 6-4, which does NAT for v6 clients to interoperate with v4 only servers. We have also created a special DHCP for IPv6 called DHCP v6 for those operators who need to manage IP addresses across their networks. DHCP v6 code written by ISC is widely seen as bringing down one particular barrier to IPv6 deployment. After, which stands for Address Family Transition Router and was developed together with ISC and Comcast, allows v4 clients to connect to v6 servers using packet encapsulation and NAT. So using after, you can incrementally migrate clients to v6 in case you decide not to fully dual stack your network all at once. ISC also offers a variety of consulting services in case you need more help than a training course can offer. And our IPv6 experience comes from many years of running a global transit network to support FROOT and our secondary name services, as well as from writing and supporting DNS and routing software. So really, ISC has been a leader in IPv6 advocacy and usage, so we are keen to help your network get ready. So some lessons that the technical community has learned, not just ISC. Don't be afraid of IPv6. Lots of folks have done it. It's just a new protocol. You put new things on your network all the time. But like anything you put in production on your network, you need to make a project plan before you deploy it, and you need to test it out. You may have a hard time selling it to non-networking staff in your organization, so you need to be ready for that. And you have to test out all of your gear and your internal software in a lab setting to see if it functions with IPv6. Your hardware should all be v6 ready and should have been IPv6 compatible for many years. Your Wi-Fi access points may be the exception to this. Most people who have done IPv6 deployments, they do their core network first, and then they do their services like mail and DNS, web, and other services, and then they roll it out to end users. That seems to be the transition path that is easiest. So if you come up with your project plan, you have to include an addressing plan, build a lab. If you don't have the resources to buy hardware, use virtual machines. Learn how IPv6 works and what doesn't work, so you aren't caught off guard when something breaks in your production environment. And we recommend that you use IPv6 as it was intended. If you use a number of transition mechanisms, it will take longer, it will be more costly, and just delay the eventual native IPv6 deployment that everyone will be doing eventually. In summary, this is going to take a long time to do. Many decades is a conservative estimate. Progress has been made, certainly in the last week, as we've already seen. The alternative to a full IPv6 transition is having two separate internets running side by side and bridged by a series of NATs. And that will bring us further away from the original peer-to-peer design of the internet as it was originally designed. So those are the lessons, and that is my presentation. Do we have any further questions before we go on to Peter? So, Peter, are you ready? Johanna is giving you the control.
Yes. Okay. Thank you, Tim. My name is Peter Losher, and I am the Senior Operations Architect here at ISC. I will be going over IPv6 support here at ISC and with our best-known service, f.rootservers.net. ISC has a backbone network which has been dual-stacked since 2002. All of our public services like web, mail, and FTP are all done both over IPv4 and IPv6. We don't do anything like having special IPv6 URLs and so forth. When you go to ftp.isc.org or www.isc.org, if you have v6 support, you'll go over v6. If you don't, it'll go over v4. You don't have to do any special wording. Both of our external DNS services, like FROOT, which I'll talk about a little bit later, and our secondary DNS service, SNS, are also built over IPv4 and IPv6. So all the name servers all answer on either IPv4 or IPv6. Our network has external IPv6 transit from many of our providers, like Hurricane Electric, Tata, Level 3, NTT, Verizon, and so forth. And we also peer dual stack over all of our IXPs in North America. So anywhere, if you look at our peering DB listing, you'll see we have V4 and V6 addresses available for peering on both networks. We also provide public benefit hosting for qualifying organizations. And IPv6 is just bundled in when they get their network connection. So when you get an Ethernet drop, when you place your server in one of our data centers, it automatically comes up with v4 and v6, usually via router advertisement. We have several guests who are using IPv6 right now, including both the Mozilla and FreeBSD projects who both serve content. With Mozilla, we help distribute their various products on our network, including Firefox and Thunderbird, over both IPv4 and IPv6. And in the case of FreeBSD, which is a Unix-based operating system, they test their IPv6 support in the OS itself with their lab their development lab that they have here on our network, because it was an easy way to help test their code in something that wasn't, say, in a tunnel broker network before, or people's tunnels. They wanted to see how it would work natively. So there's been a lot of development in OSs based on the fact that they were able to get a v6 connection early on. So right now, our current IPv6 utilization is about just over 2% of our backbone traffic, and do note that it's trending up. We tend to be ahead of the curve compared to the graph that Jim showed earlier about total web traffic, because a lot of our customers and constituents are also internet infrastructure companies like, say, the Ciscos and so forth of the world, where they may already have IPv6 enabled on the routers, or IPv6 enabled on their networks. So they're already testing it, and so we have a lot of customers who are already looking at implementing IPv6. Now I'll be focusing on f.rootservers.net. So for those of you who don't know about f.rootservers.net, or more commonly called just froot, it's one of the 13 DNS root servers. So for those of you who don't know what a root server is, it's basically a mechanism to bootstrap. So when you're typing, like, say, www.isc.org, if your DNS server doesn't know what that address is, it has to go look it up. So the first place it actually looks is actually the root server, and then walks down what we call the DNS tree, like, say, the .org servers, and then the .org servers, it'll ask the isc.org name servers, and so forth and so on. So the root servers are a basic bootstrapping method to answer DNS queries. So there's 13 of them. They're lettered A through M. And ISC has operated froot for just about over 15 years now. And about a decade ago, we started globally anycasting the service outside our backbone network. We used to be just based in the Bay Area. Now we're worldwide. Now, we've had that for about a decade, and since then, we've been testing IPv6 on a test basis. But we finally transitioned it into production in February 2008, and several of the root servers, including F, had their quad A records, which is the IPv6 version of an A record, inserted into the root zone. So all of a sudden, you had 3 or 4 root servers who had quad A records, and so you could, if you had v6 connectivity, you could actually send your root queries there. That was where we had our big network spike, because all these networks that had been testing v6 connectivity before all of a sudden had a way to send their traffic out rather than falling back to IPv4. We are now located a decade later at over 60 locations worldwide, with just over 50%, or 34 locations, IPv6 capable. This means that we have both IPv6 connectivity for management and the IXP. So normally when we stick a new froot server location, we're usually connected to a local IX, whether it be at, say, an AMSIX or an Equinix or HKIX in Hong Kong. So we try to make sure that both the IX and we get native management transit before we turn up v6 services. And so, as I said, we're now just at about above 50%. We're simply adding IPv6 wherever possible and require native, not tunneled connections, because the issue with tunneled connections is you're adding latency and so forth into the response time, because you're having to tunnel to another endpoint. And if you're in, say, the South Pacific, you're having to tunnel all your traffic all the way back to, say, California before coming back. So we try to do native transit wherever possible, and that's basically the big holdup right now for us in achieving, say, 2/3 or 90% of the effort nodes doing IPv6. Now, as I mentioned before, a lot of providers say, Tier 1 providers already do this by default. They do dual stack, but it's the second or the third tier providers, say, in the more remote parts of the world, where it's harder. They're just starting to test and bring up IPv6, and unfortunately they're learning some of the lessons that some of us who have been early adopters have been experiencing. But over time, we expect that will improve, and then we can get the corner cases where we can add IPv6 support. Now, overall, about just over 3% of X traffic is sent and received over IPv6. Most of that traffic is coming from Europe and North America, and slowly but surely we're starting to see some traffic from other parts of the world, such as Asia. You may know that Asia, especially Japan and Korea, have broad IPv6 deployments, especially with their phone networks. But unfortunately, a lot of those networks are basically isolated or walled gardens, so they really don't communicate to the outside world. So you may think that, at least for us, we would get a lot of traffic from Asia over IPv6. That hasn't been quite the case yet, but we're starting to see that come along as time progresses. But right now, we're seeing a pretty healthy chunk of this traffic come from both Europe and North America. A lot of it's going over tunnel brokers. You can easily identify them with their IP addresses, but which is good to see, and it's also growing. So I'll leave you with a map of the Anycast nodes. I'm sorry if this kind of doesn't show up quite as well as we had hoped, but basically it's all the nodes that we have worldwide, and as I said before, about just over half of them are now V6 capable. So if you are operating a network and you know your peering coordinator, if we don't peer with you already, we're happy to peer with you to have some IPv6 traffic. So with that, I'll hand it back to Tim.
Your insight and your data. If you want to hand me the ball, then I will go back a few slides to answer one of the questions. So the two questions from Bill. I've seen a lot of conflicting info in the IPv6 how-to books. For example, one book states that NAT is not part of the IPv6 strategy. However, a Cisco presenter at last year's N+1 said they were recommending NAT as part of his transition strategy. Well, you're certainly right about the first part. NAT was never part of the IPv6 design. However, many folks are currently looking at NATs as transition mechanisms because they're just not ready for to do a dual stack deployment. Jeff, do you have anything to add, or Peter?
I think there may actually be, and prepared to be corrected here, but I think there may actually be a bit of a collision of terms here. There's NAT as we've come to know it to try to solve the address depletion problem on the v4 networks, and there's another technology called NAT64, which is a mechanism being used so that people on V6 networks can access sites that only have a V4 presence. My understanding is even though NAT is used in both these cases as an acronym, that these are different technologies, and that NAT64 is really seen as a temporary transitional technology until the entire world, cross our fingers, is V6, whereas traditional NAT is a bit of a kludge to try to make it so a number of people can use a single address in the v4 network. Does that sync with other people's understanding?
Yeah, that's a very good summary, actually. So I think that answers the question pretty well. The next one, is there a canonical best practices repository? Well, I'll take a stab at that. The answer is no. Just as there is no one single organization whose mandate is to push an IPv6 transition, there are a number of different places that that you can find information. And one of them is the 6 Deploy project, which is why I put this this slide up. You can see the internetsociety.org URL there, and they've got some good information. The other places that have good information is the regional internet registries. For the US, it's ARIN. For Europe, it's the RIPE NCC. And IPv6 Now is another place to start. So you can, I believe it's IPv6now.org. There are a number of places that have good information. Peter, can you think of anything, any other really good ones? So without spending too much time on that, let's go then to Jeff's presentation. Jeff from OARC will now be your presenter.
Yes, my name is Jeff Sisson. I'm consulting engineer for DNS-OARC. Suzanne Wolf normally would have helped provide an introduction at this point, but she was unavailable for this presentation, so I will do my best to fill her shoes. First of all, just a quick overview about what's in this presentation. I'll briefly describe what OARC is, discuss a little bit about the measuring of DNS traffic on the internet that we do, and present some IPv6 statistics that may be of interest that we've seen in that monitoring. So OARC stands for DNS Operations Analysis and Research Center. It was created in 2003 by Paul Vixie as an activity within ISC, and it stayed that way for a few years until it later became expedient for it to become a wholly standalone membership organization. It's now it's a not-for-profit company that's a California charity. We have about, I'm sorry I'm taking this off the top of my head, but I believe we have about 30 members of various sizes that range from very large, well-known ISPs and vendors to small TLDs. If you go to our website, you can find a list of them. And we also collaborate with a number of like-minded organizations that do research on the internet, for instance, CAIDA, RIPE, NCC, ISC, SIE, and other organizations that have DNS research efforts. The common thread for people who participate in OARC is an interest in and a commitment to the global DNS. So OARC's mission, it's a little fluid, but it was set out with 5 key functions in mind. First of all, information sharing. In other words, OARC members participate in discussing their experiences or any issues that come up in DNS operations. Also, OARC seeks to be a clearinghouse for understanding various behaviors and characteristics of the DNS. The DNS, just as a quick aside, the DNS has sort of a life of its own. Various things happen or observed that are hard to identify or understand, and OARC exists to try to help facilitate some insight into what those are. Like, for example, large traffic spikes of queries to the root servers, or other unusual anomalies. OARC certainly isn't alone in being involved in these activities, but that's certainly one of OARC's core missions. Also, OARC conducts 2 workshops a year. And these have been generally well attended. They're usually held in conjunction with other internet meetings, primarily IETF or ARIN or RIPE meetings. And finally, OARC makes various tools and services available. Most noteworthy among those, and this is still in transition, is DSC, which is the Domain Statistics Collector that was written by Dwayne Wessels. And we intend to certainly continue to develop tools as more resources become available. One thing that OARC does that is probably one of our key functions is what we call Diddle, or Day in the Life. This is a project where we collect roughly 48, in spite of the fact that it's called a day, it's roughly 48 hours of data that we try to collect of queries sent to important infrastructure DNS servers around the internet, primarily root servers and top-level domain servers, and a few other authoritative servers that are that also have traffic that could be of interest. It's a significant effort to gather this data. It's not simply a matter of sitting at a single exchange point and grabbing all the data and putting it on a machine. All of the people who operate the authoritative servers have to voluntarily participate in this. It's a lot of work on their end. It's a lot of work on our end, and we appreciate the efforts that they all put into it. Certainly, FRoot from the start has been one of our most valuable and consistent contributors. The result is that we have a valuable repository of data going back to the first Diddle, which was in 2005. So there are probably several doctoral candidates could spend a semester or two examining this data and coming up with some very interesting data from these archives, from various behaviors that have been seen, and that the data is made available to OARC members via host or several hosts now that members can log into to run analyses on for the purpose of various projects. So this year, the Diddle Collection was held from April 17th to April 19th. We actually collect a total of 50 hours. We try to get an hour on either side just for various startup and shutdown issues that happen when people, when contributors start trying to get things running. This year, 23 contributors uploaded almost 9 terabits of DNS query data as gzipped PCAP files. And operators of 9 of the 13 root servers participated. Here's a quick graph of what the root server participation was this year. These are the number of queries that were in the PCAP files that were sent to us. As you can see, there's a lot of variation. You shouldn't read too much into these variations. To some extent, it reflects the number of queries various root servers get, but in other cases, it also reflects the amount of information that the root server operator is able to provide to us. So in some cases, well, in many cases, root server operators have multicast networks and can't provide data from every single node that they operate because that would be prohibitive. But in any case, this should give you a quick snapshot of the sort of data that we're getting from the root servers. And so the Diddle data that we collect provides a small window onto IPv6 deployment. We don't actually see IPv6 traffic in the same way that, for instance, AMSIX sees it, the way Tim earlier presented it. In fact, we don't see the traffic actually traversing Internet exchange points. But various DNS activity gives some insight into IPv6 adoption and deployment. For example, the transport used to query name servers, we do see whether people are contacting the root name servers via IPv4 or IPv6. Also, the prevalence of Quad A queries indicates, to some extent, IPv6 activities, but that's, as we'll see in a later slide, not an entirely perfect indicator. And finally, the prevalence of IP6.ARPA PTR queries shows some, it is a signature of IPv6 activity. So yeah, first of all, here's the result of looking at LRoot, the A and Quad A resource record queries that were received by LRoot during this year's Diddle. As you can see, there were nearly 2-to-1 A resource record queries compared to Quad A resource record queries to LRoot. That would suggest that a third of the Internet was using IPv6, but we definitely know that that's not the case. There are applications and situations out there that cause many more Quad A resource record queries to be generated than actually correspond with IPv6 traffic. One thing I wanted to point out about this graph is that, that's sometimes counterintuitive to people first encountering IPv6, DNS and IPv6 is that Quad A queries can happen over IPv4, and A resource record queries can happen over IPv6. And this can be due to different network architectures or setups. So perhaps a more meaningful statistic are the PTR resource record queries. This graph shows, again, for LRoot alone, well, I should just backtrack a little bit and mention a PTR resource record query occurs typically when a host wants to know what the host name is of a machine or host connecting to it. Like if it has an IP address and it wants to know what the IP address is. So in this case, you can see there are many more IPv4 PTR queries than there are IPv6 queries, and this is very consistent with the traffic that we see that Tim showed going across ANZIX. We saw one in looking at all this, and this is a bit of an aside, there was a curious PTR resource record statistic. Many more PTR resource record queries are generated by the Mac OS operating system that have nothing to do with trying to resolve host names. So just to sum up the observations, the Diddle data that we have reveals a little bit about IPv6 deployment. The Quad A, the number of Quad A resource record queries probably aren't a great indicator. However, the number of IPv6.OARC PTR queries does show that there is a small but increasing amount of IPv6 uptake. For more information about DNS-OARC, you can visit this URL. And that's it. Any questions?
Thank you, Jeff. We appreciate your participating today and giving us your data and all the work you did to collate it. Johanna, if you want to carry on, and our question box will be open for the next few minutes while Johanna gives us some more information.
Thank you, Tim, and thank you, everyone, for that very wonderful presentation. We will be starting our final Q&A session soon, but before we do that, I'd just like to mention a few quick things. ISC offers webinars, events, and trainings around the world, and here's a list of our upcoming sessions. Our webinars are always free, and we run them 3 times a day, Pacific time, 8 a.m., 1 p.m., and 7 p.m. as a public benefit service to our worldwide constituents. If you can think of anyone that may benefit from this webinar, please do let them know. We also welcome suggestions for webinar or training sessions, so if you have any topic in mind, please do contact us. We have, in terms of training, we have those trainings happening around the world, and we are constantly updating it as well. So please visit those websites for the most updated information. We have a mailing list that you could join for our technical discussions. You can also visit our knowledge-based website to read articles on how-tos, or you can also contribute to our knowledge base. We welcome your participation. Finally, as a token of our appreciation for your participation today, we are offering discounts for our training classes. So you will receive a coupon code in our thank you email following this webinar. And here are some ways that you can keep in touch with us via social media to receive the latest news from us. Okay, that's it for me. Let's go ahead and answer questions.
I guess I have a question. Thank you, Joanna. Question for Bill Kish. Bill, did I answer your question about the best practice repositories? I mean, there are many, many places I can send you. Each of the network operators groups, the NANOG for North America, Apricot, AFNOG for Africa, they each have conferences every year and a variety of IPv6 presentations. And there are a number of organizations who are sort of who do training and consulting on IPv6, and they've got presentations. But there is no single canonical best practice place, except, of course, the RFC repository, the IETF RFC repository. But learning how to deploy IPv6 by reading RFCs will be challenging at best. Good. Well, we have spent our hour, and if there are no other questions, I think that we can safely sign off. And thank you very much for your participation. We appreciate your time and attention, and thank you very much to the panelists for their work in presenting.
Thank you,
Bye-bye,
everyone.
Bye-bye, Joanna. Thank you.